In the previous session, we have discussed contains method, whether the single object is available in the array list or not. If that object is available in the list, then it is going to be written true. If the object is not available in the array list, then it is going to return false. Contains all method we have. Contains all method we have. When we are using this contains all method, when one collection is contains in this particular collection, then it will be used as true, or otherwise it is going to give as false. Next we have seen get method. What is the purpose of using this get method? What is the purpose of using this get method? In the specified index, whatever it may be the element we have, it is going to be written for us. In the specified position, whatever it may be the element we have, it is going to be written for us. Is empty is a method to know whether the method is empty or not. It will returns true if the method is empty, or otherwise it is going to return false. Sorry, if the array list is empty, it is going to return true. The array list is not empty, then it is going to be written false. Next, index of is a method we have. Index of is a method we have. What is index of? One particular object, if I am passing as an argument to the index of, if that exists in the array list, it is going to be use the first occurrence index. If this object is occurs more than one time, if this object is occurs more than one time, then it is going to be use the index of first occurrence of that particular element. Index of that particular element, first occurrence. If it is available more than one time, it is going to give the first occurrence. See here, if the particular element is not available, then it is going to be give -1. 66 is not there in the array list. 66 is not there in the array list. So because of that, it is going to give -1. Next, we have last index of method. It is used to return the index of an element or object which occurs at the last. If the object is available only one time, the element is available on only one time, that index only it is going to be displayed. Then remove method. We are going to be specify the position here. By using the remove method, one way we can able to specify its position. See here, al1 dot, this one, first one, removes the element int index. Array list object. So then what I would like to mention the comment of this. It is going to be removed and it is going to be shift its position. Next we have ArrayList object dot remove object. Directly we are passing the object. So it is going to be remove that particular object if it is existed. Otherwise, it is going to be raise the exception. Even while we are removing based on the index, in that particular case also, if that particular index is available, then it is going to be remove it. Index of integer. If I am giving this, it is going to be remove that. First occurrence of the specified element. First occurrence of the specified element, it is going to be displayed, and it is going to be remains unchanged. This remove method. So we have discussed about remove method, how it is going to be work. That is, if we are having the duplicate elements, it is going to be removes the first occurrence. Removes the first occurrence of the specified element. If it is available more than one time. It is available more than one time. AL1 dot. So we have discussed add method, add all, clear, contains all, equals, ensure capacity we will discuss, equals we have to discuss, get we have discussed, then we have index of is empty, last index of iterator we have to discuss, remove we have discussed, complete collection if you want to remove, complete collection if you want to remove, we can able to remove it. The size method we have discussed already. Size method we have discussed already. Yeah. Next, ensure capacity. First, I would like to display how many number of elements we have in AL. AL1. ArrayList object. And then ensure capacity. In the minimum capacity we are going to be getting. Minimum capacity. If necessary, it is going to be increase its size. As we said that ArrayList is going to be increases its size based on our requirement. Based on our requirement. See, now elements of ArrayList AL. ArrayList AL. I'll be displaying ArrayList AL. And next, the capacity of this AL. Ensure capacity of AL. AL dot ensure capacity. Sorry, before that, first we'll see the size of that. ArrayList AL. Size of that. AL dot size. AL dot size. If you see here, what is the size we have? Where we are getting the error? Size of 5. Size of array list AL1 is 5. Now I'll ensure that it will be having the elements as 10. Now we will see. Ensure that it can hold at least the number of elements specified by the minimum capacity argument. See, now have given this capacity as 10. Now already we have the elements as 5. AL dot add of 11, AL dot add of 22, AL dot add of 33, AL dot add of 44, AL dot add of 35. Now if you see here, array list and the size of array list as well. Size of array list as well. Now AL dot add of 66, AL dot add of 77. See, even though it is having size we have given as 10, still it is going to be store these values. Minimum capacity if you want to provide that we have given as 10, still whenever it need to be get added, it is going to be increase its size. Actually, minimum we have given 10 size. As the array list is having to grow its size dynamically, it is going to be increases its size. So because of that, whenever we are adding 2 more elements also, fine, it is going to be added to that. Any doubt as of now? Any doubt with this example? Any doubt, ask me. Now, AL dot equals of object. Something AL1, let me consider. What it is going to give? If it is true, if both are same, it is going to return true. Return true. Both are same. Both are same. Return true. . al dot equals of al2 something, where we don't have equal values and the same values in both the things, we are going to be get as false. False we are getting. See, observe that array list is maintaining the insertion order. Array list is maintaining the insertion order, and duplicate values it is allowing. Dynamically it is increasing the size. Okay, and if you observe one more thing, we are going to be add all the elements at the end of the array list. If we want to add the elements at the end of the array list, we are adding. In the middle, if we want to insert, we are inserting. By default, it is going to be add the element at the end of the array list. At the end of the array list. Okay, fine. Now, these things we have observed with all these examples. Next, linked list. Linked list is also going to be implement the collection interface. Linked list is also used for implementing the collection interface. List is array list is also used for implementing the collection interface. If it is an array list for storing the elements, it is going to be use the list data structure. It is going to be use the list. But whereas coming to the linked list, what is meant by linked list? First, I'll discuss on that. What is meant by linked list? See here. This is a linked list. Node. It's a node in a linked list. Not linked list, node in the linked list. So data link. Data link will be having here. A data link will be having here. Now, initially, if we are starting it, we'll be having starting address and then data and link, and then data and link, like this, and it is going to be half. Now, if you see here, what it will happen here, it will be having the address of this particular node. Here, it will be having the address of this particular node, and here, see, each one again will be having two parts. Each one again will be having two parts. Okay, see, this is a starting node. I'll explain. See, now, this is a starting node. Starting address will be there. Starting address will be there. So this is a data. This is a link. And this is data. See, this is having the link related to this particular node. This is having the link related to this particular node. And here we'll be having the link related to this particular node. Here we have the data. And here we'll be having the link of this particular node. At the end, we'll be having the null. Because which will represent as an end, which will be represents as an end, it will be having null over there. Okay. See, this is going to be represent the start node, where we'll be having the this node data here and link of or the reference of next node like a chain. And here we'll be having data again. Here we'll be having the link of the next node. Data we have link of next node like that. At the end we have null because we don't have next node here. We don't have next node here. This is what we can say as a singly linked list. This is what we can say as singly linked list. There will be having data and link in node. Data and link in node. Next, W linked list will be having two links and one data. See here, node of singly linked list. Node of singly linked list. And whereas coming to here, previous link, that is previous node link, node, next to node link. Got it? See, W linked list, this is a node of W linked list. It's a node of W linked list. See, where we'll be having the data in the middle. Where we'll be having the data in the middle. So here we'll be having the previous node link, and here we'll be having the next node link. It means you can observe one thing. If it is an array list, we are using the list data structure for storing the data, but still we are going to be store the elements at the end of the list. At the end of the list. Whereas if it is a linked list, we can able to add an element at the beginning of the list, ending of the list, or in the specified position as well. Linked list, in the linked list, we can add the elements in the specified position as well. We'll see that. We can store duplicate elements. It maintains the insertion order and it is not synchronized. See, manipulation is fast because no shifting is required. Automatically, it is going to be attached in the specified position. Because of that, no shifting is required here. And we have syntax for creating the linked list. Syntax for creating the linked list. List data type list object, new linked list, or directly we can give the linked list. So we'll see that. See here, linked list ll1 new linked list. So here we have to import related package. We have imported the related package. Linked list is a class which is implementing from the collection interface. It is available in the java.util.linked package. Okay, and now if you see ll1 dot add object, which we know for adding the element to the end of the list. See here, linked list object add object E, because we didn't specify any data type over here. If we specify the data type, then it is going to be asked which type of data we have to store in it. Which type of data we have to store in it. Okay. And now here we didn't specify, because of directly it is going to be stored the object. Okay, object E. It's the specified element at the end of the list. Okay, add to, we are adding ll1 add ll1 dot add 4 ll1 dot add 5. Now we are going to be display all the elements. Linked list ll1 linked list ll1, we are going to be display that ll1. Okay, it is going to be display the elements. It is going to be display the elements. Now see ll1 dot add index in the specified position. In the specified position. See here, linked list object add int index object. In the second position, I would like to store 22. ll1 dot element add. Here the size is 5, 6. In the seventh position, I would like to store 77. The seventh position, I would like to add 77. See, In the second position, we are getting 22. Size is 6. 0, 1, 2, 3, 4, 5, 6. Yeah. 77 is added in the sixth position. And in the second position, 22. That is 0, 1, 2. In the second position, it has been added 22. And in the sixth position, it has been added 77. The same way, we have add all, which is used for adding the collection. In the specified position, if we want to add collection, we are going to be use add all int index collection C. See, already we have LL1 as a linked list. When we want to add that the other linked list, we'll see. I'll create some linked list. Let me say that is LL2, LL3 as well. Okay. Now, LL2 dot add collection, add all collection of LL1. Now, whatever may be the elements we have in the LL1, all the particular collection will be added to LL2. See here, linked list LL1, linked list LL1 is going to be displayed. And after adding this linked list LL2, before adding it will be empty. Before adding it will be empty. Okay. And now see here, I'll display once the linked list LL2. The linked list LL2. So what we are getting here? Now here it is empty list, it is going to be displayed. Here it is going to be display empty list. Here it is going to be display the LL1 element. And we are adding LL1 to the LL2 complete collection. So then it is going to be have the complete LL1 into LL2. So as we said here, it is going to be give the empty. And this is a LL1 elements we have. And the same we are getting this one. In the specified position, if we want to add LL2 dot add all in the specified position, so what we are getting in the second position, I want to add LL1. See, it means here this is a 0, this is 1. In the second position, it will start getting all these elements, and then remaining all this will be getting from the next position. In this particular second position, we are getting this, and then it is going to be continue the remaining elements in the linked list. Okay, we'll see that. In the second position, it has added all this one. If you see here, this is 0th position, one position, and in the second position this has been started, and the remaining will be continued. Okay, next, along with this, so this is common when compared to the array list. Add in the specific position, if you want to add an object or element, add all which is used for adding the collection. In the specified position, if we want to add the collection, we can use this, which is common to the array list. Now ll2 dot add first, which is useful for adding the element at the first Java. Add first, I've given Java. ll2 dot add last Python. Add last Python. See here, ll2 dot add first object E. Linked list object add first object E linked list object add last. What are the methods? If the method is holding two words, method is holding two words. In the first word, first letter should be small letter, that is lowercase letter, and in the second word, first letter should be uppercase. This is what we can say as camel case. That is what we can say as camel case. Okay. Mostly we'll be getting inbuilt methods also like that only. If we add first, what is going to be happen? ll2 dot add first, which is useful for inserting the specified element in the beginning of the list. Inserts the specified element at the beginning of the list. Inserts the specified element at the beginning of the list. Add last appends the specified element at the end of the list. And finally, we'll display the elements of linked list. Initially, first it has to be start with Java and it has to be end with Python. Linked list ll2 linked list ll2 first it has been started with Java and it has been ended with Python. Any doubts in these concepts? If you have any doubts, you can ask. Remaining methods for that examples we will discuss in the next session. If any doubt, you can ask.